So let's look at another example of analysis for the relation between two variables. In this example, we're going to look at the relation, if one exists, between square footage and the selling price for homes. So I have some data, and I've actually already put that into my calculator in list 1 and list 2. In list 1, I have the square footage for various homes, and next to that, I have the selling price. This is in thousands of dollars. So for instance, the first number there, 627.7, would indicate $627,700. So let's look at the scatter plot. Hitting zoom, option 9. So right away it looks like there's an upward trend. So there's a positive association. That's not surprising. Larger homes generally sell for more, so that I'm not surprised to see an upward trend. And as far as whether there's a pattern here, I think it's safe to say that there is a linear pattern. So let's look at our calculations. I want to go from my stat menu to the calculations and get the linear regression and the values of r and r squared. So r in this case is 0.90, and I'm going to round up 4 decimal places, so 26. I'm going to go ahead and make a note here that r squared is 0.8146. My slope is 0.1563, and the y-intercept is 14.8740. So before I can say whether or not there is a linear relation, I want to look up the critical value. In this data set, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I had 12 homes in my sample, and so I'll look over to my table of critical values, and here I see for 12 the critical value is 0.576. So r is definitely greater than the critical value here. This is a positive r value, so I don't, in taking the absolute value, I'm still going to end up with 0.9026, and that's definitely greater than the critical value. So I think that there is a linear relation here, and my regression equation looks like this. Y hat equals 0.1563x plus 14.8740. The slope is 0.1563. So let's interpret the slope. So for every additional square foot of actually, I'll just say for every additional square foot, the home value, in this case, increases by how much? Let's see, 0.1563. Now, we have to think about this. This is actually in thousands. So if you wanted to say 0.1563, thousands of dollars, I think the more concise way to say that would be to move the decimal place here and say that increases by 156 $1,300, and so we're combining both the units and the. That seems like an awful lot. Maybe make sure that I'm. This is 1563, and that was in thousands. And let's go back to our. Oh, I know. Well, this is a good point. Does this make sense? So let's make a few predictions. Let's say that we have a home with the square footage. Let me go back to the original data set. No stat. So it looks like the home values, the square footage that we were using here was, in the 1 to 3,000. There's a house with a square footage of 4,000. Now, does it make sense? Let's say that I have a home that's 2,000 square feet, and I use this prediction model. So I'll go back to my home screen and say 0.1563 times 2,000 plus 14.874. So that corresponds to 327.474. Now I know that that's in thousands, so that's actually $327,474. So this is square feet, and that's in dollars. Now, what if I make a prediction for a house that's just has one additional square foot? Let's see what happens here. So I would take 0.1563 times 2001 and add 14.8740, and I would get 327,630. So the difference there, an additional square foot, I actually only made a difference of, let's see, that minus 327,474. Oh wait, no, okay. 327,630 minus 327,474, 156. Oh yeah. I was moving my decimal space too much. So this is in thousands. So this would be 1, 10, 100,000, 150, not 156,000, but $156.30. That makes more sense. All right. When you get a result that seems unreasonable, it probably is. And so this was a good way to figure out where my mistake was. Okay, so there is this. The home value increases by $156. We'll say that. All right. Now, what about the y-intercept? Does it make sense for us to interpret this? If a home has 0 square feet, are we really going to try to predict its home value? I'd say not. So we will not make a prediction when the home value is 0. But let's look at r squared, and that was 0.8146. So we can say that 81% of the variation in sales price is explained by the regression on square footage. All right, so here we have another complete analysis, this time of the relationship between square footage and selling price. So we started with a scatter plot, did a visual analysis, then we calculated the correlation coefficient and compared that to a critical value. That prompted us to find the regression equation. We used that to make a couple of predictions, and I interpreted the slope. I decided not to interpret the y-intercept, and then lastly we looked at the coefficient of determination, r squared, and interpreted that as a percentage of variation explained by the regression.